In October 2017, a discovery shocked the scientific world and set off a wave of speculation and excitement. The Pan-STARRS Observatory in Hawaii captured something unprecedented, an object speeding through our solar system from outside it. Dubbed Oumuamua, which means scout or messenger in Hawaiian, this object was more than just an interstellar visitor. It was the first of its kind ever detected, challenging scientists' understanding of space and sparking questions that we've barely begun to answer. What set Oumuamua apart from any other celestial body we'd encountered was its extraordinary shape, behavior, and origin. Traditional objects from our solar system, like comets, asteroids, and even meteors, have predictable forms and characteristics, but Oumuamua wasn't like anything we'd seen before. Its elongated, cigar-like shape, rapid speed, and unusual trajectory quickly raised eyebrows. As scientists raced to collect data during its brief appearance in our solar system, they realized this object held secrets that could change our understanding of the cosmos. With telescopes around the world turned toward this unexpected visitor, astronomers were left with just a few short weeks to study Oumuamua before it would slip away into the depths of space. The questions surrounding it grew with every new observation. Why did it accelerate unexpectedly as it moved away from the sun? Why didn't it have the tail or coma usually associated with comets? Could it be a natural object, or was there a possibility, however small, that it was something artificial, perhaps even a probe from another civilization? As we continue to search for answers, Oumuamua remains a fascinating mystery, a puzzle that reminds us of how little we still know about the universe. Hashtag Part 1. What makes Oumuamua unique? When Oumuamua was first spotted, astronomers quickly noted its highly unusual shape. Based on limited observations, scientists estimated that it was at least 800 to 1,000 meters long, possibly stretching up to a kilometer. However, its width was much smaller, with estimates suggesting a ratio of 10 to 1, meaning it was 10 times longer than it was wide. In the realm of known space objects, this shape is practically unheard of, with most asteroids and comets exhibiting more spherical or irregular forms. This slender, elongated shape led to much speculation. Was it the shard of a larger object that had broken apart? Or could it be some form of alien technology? Perhaps a solar sail? Its rotation added another layer to the mystery. Observations indicated that Oumuamua was tumbling through space, not rotating in a smooth or predictable way. This erratic spinning created rapid shifts in its brightness as different parts of the object reflected sunlight at various angles. The way Oumuamua flickered, almost like a cosmic lighthouse, led scientists to believe it might have an unusual surface composition or texture. Some hypothesized that its shape and spin could be the result of a cataclysmic event that ejected it from its home system millions or even billions of years ago. Hashtag Part 2. Theories on Oumuamua's origin. As scientists studied Oumuamua, theories about its origin multiplied. One of the first ideas was that it might be a fragment of a larger body, possibly a planet or moon, that had been shattered by a massive collision. If such a body were ejected from its home system, it could travel through interstellar space for countless eons, shaped by impacts and gravitational interactions along the way. Another compelling theory was that Oumuamua was a type of interstellar comet. Though it defied traditional definitions of a comet, usually characterized by the emission of gas and dust when passing close to the sun, forming a visible tail, no such jets were detected around Oumuamua. This ruled out typical comet behavior. Some scientists speculated it could be composed of unusual materials like nitrogen ice or even hydrogen ice, which could sublimate without leaving a visible trace. However, these materials are rare and would need to withstand an incredible journey through interstellar space, making this theory less likely. One of the most extraordinary hypotheses came from Harvard astrophysicist Avi Loeb, who suggested that Oumuamua might be an alien probe or a fragment of advanced technology. Loeb proposed that the object's shape, acceleration, and lack of a traditional tail could indicate that it was a solar sail, a lightweight, highly reflective structure propelled by the pressure of sunlight. If true, this would suggest that Oumuamua was intentionally sent to explore, possibly by a distant civilization. Though controversial, Loeb's theory added a provocative dimension to the debate and highlighted the limitations of our current understanding of interstellar objects. Part 3. Tracking the mysterious trajectory. Oumuamua's path through our solar system was as unusual as its shape. Unlike most objects that enter our solar system, Oumuamua came from above the ecliptic plane, the flat, disc-shaped region where most planets and objects orbit. This unique approach meant that it didn't interact with any major planetary bodies, leaving scientists puzzled as to how and why it took this route. Even more bizarre was the fact that Oumuamua sped up as it moved away from the sun. This unexpected acceleration defied explanations tied to gravity alone. While comets can sometimes accelerate when their ice sublimates and produces jets of gas, no such jets were detected around Oumuamua to account for this. Some researchers proposed that the object could have unknown physical properties or a rare composition, like solid hydrogen or nitrogen ice. Alternatively, it might even have mechanisms we don't understand, hinting at possibilities beyond natural explanations. Scientists used the Gaia spacecraft to try to trace Oumuamua's origin, but the results were inconclusive. Its trajectory suggested it might have come from the direction of the Lyra constellation, but without a clear starting point, its true origins remain a mystery. This is where the hypothetical paths offered by simulations come in. They suggest that Oumuamua could have wandered through space for billions of years, crossing countless star systems before entering ours. The difficulty in pinpointing its origin highlights how little we know about interstellar space and the journeys objects can take through it. Part 4. Scientific perspectives and the debate over alien technology. The question of whether Oumuamua could be alien technology brought in scientific heavyweights with opposing viewpoints. Avi Loeb's controversial stance suggested that if we don't consider the possibility of alien technology, we might miss evidence that could change our understanding of the cosmos. According to Loeb, the object's high reflectivity and unusual acceleration could indicate artificial construction, like a solar sail designed to move through space using radiation from stars. Other scientists, however, argued for caution, emphasizing that extraordinary claims require extraordinary evidence, and the current data on Oumuamua doesn't conclusively support the alien technology theory. These researchers suggested that the strange characteristics of Oumuamua might be due to factors we simply don't fully understand yet about interstellar objects, such as unknown compositions or forces that could account for its odd behavior. The debate over Oumuamua also highlights a philosophical aspect of scientific exploration. Should scientists remain open to hypotheses as extraordinary as alien technology, even with limited evidence, or should the burden of proof be so high that such theories are dismissed without rigorous evidence? This debate reveals the limits of our knowledge and the human tendency to question everything we observe in the universe. Part 5. Limitations in observation and the race against time. The fleeting nature of Oumuamua's visit presented unique challenges. By the time it was discovered, it was already on its way out of the solar system, leaving astronomers with only weeks to gather as much data as possible. Current technology allowed for some observational opportunities, but limited resolution prevented detailed images, forcing scientists to rely on indirect observations, such as brightness fluctuations, to infer its shape and behavior. If Oumuamua had been detected earlier, more extensive studies could have been conducted, possibly revealing more about its composition and structure. This experience has underscored the need for advancements in our ability to detect and study interstellar objects. Future missions, such as ESA's Comet Interceptor, which is designed to wait for objects like Oumuamua and intercept them, could bridge this gap in observational capabilities. Part 6. Proposed future missions and the role of Project Lyra. Project Lyra emerged as a proposed mission to intercept Oumuamua, even though it's already moving rapidly out of our solar system. The mission would require an extraordinarily fast spacecraft capable of traveling over 20 kilometers per second to catch up with Oumuamua, potentially using gravity assists from planets like Jupiter or Venus to accelerate its speed. However, reaching Oumuamua would still take decades, requiring careful planning and significant resources. Such a mission could cost billions, raising questions about the value of sending a spacecraft after a single object. Yet, if Oumuamua holds secrets about alien technology or interstellar origins, the potential scientific payoff could be monumental. Project Lyra's ambitions reflect humanity's deep curiosity and willingness to pursue answers, no matter the challenges. Part 7. Comparing Oumuamua with other interstellar objects. Since Oumuamua's discovery, another interstellar visitor, Comet Borisov, has been observed, providing a point of comparison. Unlike Oumuamua, Borisov displayed characteristics typical of a comet, including a tail and gas emissions. Studying Borisov has helped scientists understand what a more traditional interstellar object might look like, but it has also highlighted Oumuamua's unique nature. This comparison suggests that interstellar objects may come in a wider variety of forms than previously thought. If other Oumuamua-like objects are detected, it could indicate that elongated shapes and rapid spins are more common in interstellar space, possibly due to unknown formation processes. These discoveries push us to reconsider what we assume about the nature of objects traveling between star systems. Part 8. Implications for the search for extraterrestrial intelligence. SETI. The excitement surrounding Oumuamua has implications for SETI, the search for extraterrestrial intelligence. Traditionally, SETI has focused on detecting radio signals from advanced civilizations, but Oumuamua raises the possibility that some alien civilizations might instead send probes or other physical objects to explore the galaxy. The idea of Oumuamua as an alien probe may sound far-fetched, but it's not entirely implausible. With no conclusive evidence of alien radio signals, some scientists are beginning to consider the possibility of non-radio-based exploration methods. If Oumuamua were indeed an alien probe, it would suggest that advanced civilizations might use unmanned interstellar scouts to gather information about other star systems, a possibility that could reshape SETI's approach to finding alien life. Part 9. Reflections on humanity's place in the universe. Ultimately, the mystery of Oumuamua is a powerful reminder of how much we still have to learn about the universe. Our encounters with such objects encourage us to question our place in the cosmos and push the boundaries of human understanding. For all we know, there could be countless other Oumuamuas out there, each one carrying secrets from distant stars or even hints of other civilizations. The discovery of Oumuamua has prompted humanity to ask deeper questions about the universe. Are we alone? Are there other civilizations exploring the stars just as we hope to do one day? And if so, what might they want to learn from us, and what can we learn from them? The answers to these questions remain beyond our reach, but the journey to discover them is as thrilling as the mysteries themselves. As Oumuamua drifts further from our solar system, taking its secrets with it, we are left to ponder what it might have been and what else lies beyond the stars. Whether it was an alien probe, a fragment from a distant system, or something entirely different, its brief visit has left a lasting impact on science and our imaginations. The quest to understand Oumuamua is far from over. With new technology, future missions, and our unyielding curiosity, we may one day solve the mystery. Until then, Oumuamua serves as a tantalizing reminder of the universe's boundless possibilities. As scientists and explorers, we look forward to the day we can welcome another interstellar traveler and perhaps find the answers we've been searching for. As the mystery of Oumuamua continues to unfold, it has sparked a broader interest in the study of interstellar objects, raising new questions about their potential to reveal more about the nature of space itself. The sheer novelty of an object from another star system entering our solar system has forced scientists to reconsider how we detect, analyze, and categorize such visitors. Beyond the intrigue surrounding its shape and behavior, Oumuamua challenges our understanding of the processes that govern the dynamics of objects in interstellar space. One of the most compelling aspects of studying interstellar objects like Oumuamua is the potential to learn about the conditions in other star systems. Objects that originate from distant stars could carry with them valuable information about their home systems, insights into the composition of their home planets, the potential for habitable environments, and even clues about the star system's evolutionary history. If future missions are able to intercept and analyze similar interstellar travelers, they could provide a wealth of data that would be impossible to obtain through other means. The technology required to detect and study interstellar objects is advancing, but it's clear that significant leaps will be necessary. As we refine our observational tools and develop new missions capable of reaching distant visitors, our ability to analyze these objects in real time will improve. Innovations in space telescopes, such as the James Webb Space Telescope, could offer more detailed observations of future interstellar objects, helping to unravel their origins and behaviors. Additionally, the construction of specialized spacecraft designed for interstellar exploration could be the key to unlocking the secrets of these enigmatic visitors. The continued exploration of interstellar objects like Oumuamua also feeds into larger discussions about humanity's future in space. As we look to the stars for answers, these objects may provide clues not only about the past, but also about what lies ahead in humanity's quest to explore and colonize other star systems. Whether through robotic probes or eventually human missions, the search for knowledge about interstellar space is only beginning. Oumuamua serves as an exciting symbol of what might be discovered, pushing the boundaries of human exploration beyond our solar system. As we continue to study interstellar objects like Oumuamua, they may also offer indirect insights into the future of space travel. The nature of such objects raises questions about the long-term survival of material in space and the forces that shape these celestial travelers. Understanding their composition, structure, and behavior could eventually help scientists design more durable spacecraft, capable of withstanding the harsh conditions of interstellar travel. Additionally, Oumuamua has sparked conversations about the possibility of using objects in space as resources. Could such objects be harnessed for scientific study, mining, or even as stepping stones for deeper space exploration?